Make sure I got the clicker and everything's ready to go here. So good afternoon or morning or wherever we're at. Thanks, Jeremy, for the intro. And just to introduce myself, I'm CTO at Rackspace. I've been at Rackspace for almost 11 years. And nowadays I spend a lot of time talking about cloud. So that's what I'm here today, to sort of tell you about a little bit about what we're doing, but a whole lot about what I think is happening in the cloud. I don't really want this to be any kind of sales pitch for Rackspace. I want it to be about sort of a trend that I see in the industry and in the cloud especially. So there's my contact info. If you ever want to get in touch, there it is. Let's see. So Rackspace, what do we do? I think most people may have heard of us, but our roots are in hosting. Cloud is really the thing that we're focused on nowadays and spending a lot of time on. We've got lots of products and services, but leave it at that. We're a hosting company that's being transformed into a cloud computing company before your eyes. One of the things that sort of sets Rackspace apart, this is important. It's not, again, trying to give you a sales pitch, but it's important later on in the presentation. The thing that really sets Rackspace apart is this concept of great customer service or fanatical support. The technology is important to us, but what we do on top of the technology is even more important. And so as we think about cloud and cloud technology, we need access to it, but it's not the thing that differentiates us as a company. We don't need it to be sort of unique to Rackspace. So that's what fanatical support's all about. We really sort of believe in great customer service, and this to the very core of the company. It's in our DNA. It's who we are, and you'll hear it every time you see Rackspace. So everyone's going to the cloud. Obviously, this is a great event. We've got lots of attendees here. We've got RightScale next door. We've got really these kinds of. I go to a conference a week, it feels like, and there's a topic around cloud computing. And so why is it happening? We know why. It's the speed, time to market. It's the lower cost. It's revenue. Making sure you're making revenue on a lower cost base. Getting things into the market very quickly. Those are all well-known things. We at Rackspace think about now from our customers' perspective, they recognize the value of cloud, but do they understand what to do next? How do you go about using the cloud or building a cloud if you want to build your own private cloud? We have a lot of customers who really think about this when they come to a conference like this, and it gets confusing. You hear a lot of messages from a lot of different people. There's plenty of them out here on the show floor. Everybody has their own perspective on cloud computing and what you should do and what you should buy and who you should buy it from and how you should build it. Again, everybody has a message. I love this. I had to put it into a presentation here. This is Grandpa Simpson saying, he's confused about it because everywhere you look, it's really a different message coming from a different vendor. So yelling at the cloud is sometimes how I imagine CIOs, sort of at these events. They just don't necessarily know exactly what to do. There's a couple of, I'll break the next couple of slides into a couple sections. A lot of people are embracing the idea or the concept of public cloud. Public cloud is sort of the obvious thing that's out there. There are a number of vendors offering it. The challenge sometimes with public clouds, and this is what we hear a lot from customers, one of the things that makes them reluctant to use a public cloud is sometimes the concept of lock-in. And you hear that at almost every presentation. Lock-in is the challenge. And if your public cloud technology, the stack that powers your public cloud, only runs at one vendor's location, then you sort of do have a concept of lock-in. You're going to start to use their services, their APIs, their model for how cloud resources get deployed. And that does sort of lock you in. If you decide later on that you want to move to a different provider, you've got to rewrite at least a significant portion of your architecture. It may not be the application itself, but it's the software that makes the application do what it does in terms of elasticity and in terms of consuming different data services and storage services and whatnot. So I put a few logos up there. I'm not picking on anybody. I'm just saying that generally speaking, public clouds today, the way that they've been deployed historically have been this vendor has their view, this vendor has their view, and that's a problem for some folks that really want to deploy in the cloud. So the other side of the coin is private clouds. A lot of people think, okay, well, I'm a big enterprise. I'm a Wall Street bank, or I'm a big Fortune 500 company, or even a startup that has a significant chunk of money. They think, okay, I'll build a private cloud. That will give me the same tools and technologies and capabilities that the public cloud has, but I'll have it on my terms. I'll have it in my data center. And so you start to think about, where am I going to build a private cloud? What tools am I going to use? What technologies am I going to use? And here's another set of problems. You're sort of exchanging one problem for another with private cloud. Oftentimes, the private cloud message is, come buy our equipment, come buy our network gear, come buy our virtualization stack. We'll put it all together in a box for you, and it'll be very tightly integrated and tightly packaged. But that's a problem too, because in some ways, you're not really getting the full benefit of cloud computing, the ability to build a flexible architecture and infrastructure, have something that's modular. People like those concepts. People like the idea that they can sort of build what they need for their type of application. It's sort of not a one-size-fits-all world anymore, and so it's hard for me to imagine that something that sort of ships as a bundle is going to meet all your needs anyway. So, in some ways, this puts you back where you started. When people think of public clouds, they often think of, sort of these massive scalable architectures built on commodity equipment, low-cost services, things that drive cost out of the equation. And in some ways, if you're buying from a packaged enterprise-type vendor, you're really putting cost back into the equation. It's very expensive. It's sort of business as usual. A big service contract comes with it, a big ongoing maintenance agreement, and lots of licensing costs. So that's a problem for a lot of companies too. On the other hand, if you take those two approaches and you think about what open source did to the world, 15 years ago or 12 years ago or whatever, Linux had a big impact on our world as IT folks. It sort of showed a different way. It showed a different model for consuming software, for writing software, for building applications. A lot of things started to make their way into the open source community I always look at Linux as the root of all this. That's what really kicked off the open source movement. But so much happened after that. So many new technologies were invented in conjunction with it and on top of it, and really an ecosystem grew up. So I think Linux disrupted traditional enterprise IT. It made it better in a lot of ways. It's certainly today very much coexisting, continues to coexist with enterprise IT. It didn't replace it, but it does have a role to play, and I think that's an important factor. So real quick, how many people in the room, just to give a show of hands, how many people use open source in their day-to-day operations? Okay, so that's a lot of the room. A good percentage of the room raised their hand there. I don't know if it's 100%, but it's probably 80 plus. So open source obviously is something that's now cemented in our minds as something important. It is something that's prevalent, and I think what's going to happen is that the same way that internet technologies were built on open source, I think cloud is going to be built on open source. If you look out there today at Rackspace, for example, there are literally tens of thousands, hundreds of thousands of websites built on the LAMP stack, Linux, Apache, MySQL, PHP. That's a very well-known stack today, and you can sort of interchange some of those components. If you want to build on Python, you can do that. If you want to build on a different, Postgres for your database, you can do that. But generally speaking, this is sort of what's emerged as the common way people deploy lots of internet apps. And I think the same thing's happening in the cloud. My prediction, and I believe it's sort of happening as we speak this year, I'll claim the year of open cloud, but the cloud will have an open source operating system. And I use that term operating system because in some ways, that's what we're putting together. The same way we put together an operating system and stack of services to power a website, now we're putting together an operating system for the cloud. It's happening now. So OpenStack is something that I'm particularly excited about. This project actually launched last year, but it really got momentum over the course of 2011. How many people have heard of OpenStack? Okay, so half the room. That's good. So I'm not preaching to the choir here. So there's a few people out there I still have to evangelize to. So OpenStack is a project that launched summer of 2010. It is a true open source project. It's designed to be cloud software to power, at this point, primarily infrastructure cloud. So infrastructure as a service is what we've tackled so far. But really it's, again, true open source. We had to build a lot of our own software years ago. This is the sort of slide that shows you all the stuff that Rackspace is offering in the cloud category. And OpenStack gets its foundations from the software that we had to build on our own. Back in 2007 and 2008, we went out to the marketplace, like some of you are doing, and looked around at which vendors could help us build a cloud. Amazon had a big cloud sort of up and running. Rackspace needed one really badly. We wanted to make sure we weren't left behind. And so we looked for vendors. We looked for storage vendors that could build us a cloud. We looked for virtualization vendors that could help us build a cloud. We looked for anybody, enterprise software vendors, but really none of them had a very good story. I mean, some of them did around building like a test cloud or a small capacity cloud, but if you wanted to go head-to-head with Amazon, it was going to be really difficult to do it with heavy, expensive enterprise software that didn't scale and didn't really work for our needs. We had massive numbers of customers, so we needed true multi-tenancy in the cloud. We had the need to run it on very low-cost equipment because we were competing with somebody who that's their business model is taking fractions of pennies out of the equation. So we needed our own software, and that's what we did. We started building some components of this. We built a storage architecture. We acquired a company called CloudKick a few years back that helped, or I'm sorry, SliceHost. We CloudKick too, but for a different reason. SliceHost we acquired to help us build our compute cloud. We needed a compute cloud to go with that storage. And so we started to get these pieces together, developed by Rackers, by employees of Rackspace. That in itself was a challenge because we were transforming ourselves little by little from a hardware infrastructure network kind of a company into a software company. Software, it was a new thing for us. I mean, we weren't really historically somebody who had to hire lots of developers and staff teams of developers and build sort of organizations around writing software. So we did it though. We knew we had to do it because it wasn't available off the shelf. So our goal with all of that work was to turn commodity hardware, the way that we racked and stacked servers, we wanted to turn it into a cloud. So that's where OpenStack, again, got its roots. We built a lot of that software, but at some point we decided, we looked back at that little statement I made earlier that Rackspace is a service company. We said to ourselves, well, if we're a service company, if we're a company that values the services above the stack, then why does the stack have to be 100% controlled by Rackspace? Why do we have to keep it sort of proprietary behind the walls? Why can't we contribute it to the open source community? We use a lot of open source. We were contributing to some open source projects in a small way at that point, but why couldn't we go out to the community and start to get a little bit of help on this and get some people to start thinking with us on how to architect and build massively scalable service provider style clouds? So OpenStack was born. Primarily, Rackspace and NASA were the two original contributors. We sort of came across NASA's sort of mission, I'll use that term, mission to open source their cloud technology. They had built one that they call Nebula. And so the combination of the Rackspace cloud storage code and the NASA cloud compute storage code, or cloud compute code, I should say, the combination of those two really became the foundation for OpenStack. And we launched it in the summer 2010. We got a couple other partners on board early on. There's quite a few, but Citrix and Dell were two fairly large contributors. Citrix had an interest in cloud computing because they make a hypervisor that's arguably the most prevalent hypervisor in the cloud today. So Amazon uses Zen, Rackspace uses Zen, a couple of other folks. So the biggest clouds in the world are using Zen. They wanted to make sure Zen worked for other service providers. They wanted to start to use some of this technology for their own needs. And then Dell, longtime friend of Rackspace, Dell was a company that had a business that they call Data Center Solutions. So DCS was, their mission is to help cloud companies build their hardware and infrastructure. They provide a lot of the hardware behind most of the clouds that you guys are aware of. And they do it with some sort of different flavors of hardware. They don't take their enterprise gear and ship it to these cloud providers. They build sort of custom-made gear. So they had a great story around hardware, but they didn't have a great software story. What do we put on top of all that hardware that we're shipping? So that's why I think these guys were all interested. They wanted to make software that could make a cloud anywhere, not just public clouds. This is also for private clouds, on-premise clouds. Service providers are certainly a big target, but also big enterprises. An ecosystem started to form. That was a part of this, to get some innovation from people outside the walls of Rackspace and NASA. We knew that there were folks out there that had some good ideas and wanted to contribute them. Flexibility, this is very important. I think everyone that I've met has a sort of a different mix of use case for their cloud. Sometimes they're doing scientific computing like NASA's doing. Sometimes they're doing financial simulations like the Wall Street guys are doing. And then sometimes it's plain old straightforward web hosting and enterprise computing like we do at Rackspace. And so everybody has a little bit different vision of how a cloud ought to be built. And so we want to provide flexibility in the deployment and the features that go into a cloud. We don't want it to be a one-size-fits-all world. To that end, if you think about Citrix, we mentioned that their hypervisor is in the stack today, but this project is hypervisor agnostic. It means that you can run today on Xen and KVM or VMware or Hyper-V. All four of those, plus a few more that you probably never heard of, are all supported within the OpenStack cloud framework. So, if you have already deployed today on one of the other hypervisors and you don't want to switch, well, that doesn't really make a difference because you can bring in OpenStack and layer it in conjunction with existing technology. Again, flexibility in those deployments and the features. Standards. Standards is another big reason why Rackspace launched this. We had worked with a few standards bodies, people that were sort of officially trying to create standards for cloud computing, standards maybe in the APIs or standards in the way these clouds are built and architected. But there were a number of false starts in the standards efforts. A lot of people tried their best and had good intentions, but without technology going hand in hand with the standards work, it's sometimes hard to imagine where for the standards guys where the cloud is going to go in the next few cycles. Is it going to really follow the path that we've laid out, or are they innovating on their own? And also without support from somebody fairly large, standards have a hard time as well. Some of the biggest clouds in the world were sort of unwilling to come to the table in some cases, and so that was a problem. So it was a bunch of little guys and some guys that were actually real cloud operators getting together, but sort of not really making a real difference in terms of standards. So we think this is a place for standards to be discussed and implemented and talked about and worked on, all in conjunction with actual real deployments of clouds. Not to say this standard is 100% what it will be forever. I mean, it's not like we're telling you it has to be this. In fact, today there's even discussion around the APIs and the standards behind it, but at least it's a place where things are going to get implemented and going to possibly get standardized. You need sort of that gravity around something to get that to happen. And then the last thing we wanted to solve was the fear of lock-in. If you use a cloud provider that's using OpenStack, you're not locked in because you can choose another cloud provider using OpenStack. You can run it yourself in your own data center. You can build a private cloud in a hosted data center like Rackspace if you want. All of those are options, so you have a backup plan if your cloud isn't meeting your needs for one reason or another. So what's in OpenStack? Three components were really there at launch. There's a whole bunch more coming, but essentially a compute cloud component to build your virtual machine, on-demand kind of cloud computing product or service. An object storage, we talked about the fact that Rackspace contributed a big chunk of code for storage. This is what we call object storage, and I'll use that term object because it's meant for files and videos and archive data, things that are more or less static data, large volumes, immense volumes of static data. NASA had a real need for this. If you think about what they do, they create data from all the probes and missions and things that they do. They're the #1 largest creator of data in human history, and so they need a place to put all that data. They used to use a lot of tape drives. I remember seeing this documentary and all these old tapes that are used at NASA to store the old videos and the data that they've collected over the years. But those tapes are deteriorating, and they need a place to start putting them onto disk. Disk is the way forward. And so this is basically a way to store billions of files and objects, petabytes and petabytes of data. I think NASA may actually have a bigger storage cloud than even we do, and they just sort of started building it. And then this last piece is the image service, the OpenStack image service. This actually kind of uses both of these services, or it brings them together in some way. Anytime you boot up a compute instance on the cloud computing side, that instance needs to be stored somewhere. So the files and the configurations and all the things that are associated with that virtual machine image, those get stored in the object storage, or they can be stored. And they also need a way to catalog those and share them and keep track of them, and that's what the image service does. So those are the original kind of components of OpenStack. We just had a couple of weeks ago, 2 or 3 weeks ago, we had what's called a design summit, and that's really just a gathering of all the OpenStack geeks that want to contribute code and want to talk about it. They sort of launched a few more projects. You can actually go read about them at openstack.org in the community website, but there's like a network as a service, there's storage as a service, there's database as a service. There's a few other projects now sort of in flight and more to come. So this is now sort of a growing set of services that are under the OpenStack banner. Now, I'm going to stop and change gears for a second because I want to talk about ecosystems for a second. Ecosystems are very powerful. This one is one that it's hard to deny the power of an ecosystem. Everybody knows Apple's iPad and iTunes and the MacBook and the iPhone 4. They're huge gravity around that ecosystem. Ecosystems certainly can make or break a company. If you're part of the winning ecosystem, you're in good shape. If you miss it and you get on the wrong bandwagon and you choose the wrong set of technologies or services, sometimes you're forced in the long run to sort of go back and retrench and go a different direction. And you see that today with some of the biggest mobile phone guys in the world sort of figuring out, man, I've missed the mark. There's the whole world is moving a different direction. So ecosystems really matter. Ecosystems also have had a role beyond just music and mobile devices in operating systems. If you think about operating systems in history, go all the way back to the origins of computing. And the ecosystems were a little simpler back then, but they were still ecosystems. You had mainframe ecosystems. You had sort of mid-range Unix computing ecosystems. So let's walk through some of those examples, patterns of ecosystems. Solaris, I'll use that one because I remember in my college days there was every lab in the college had a Unix machine on it, and that Unix machine was oftentimes a Sun machine running Solaris. So I always look back in my history as them being a visionary in computing. They invented a lot of stuff. They really helped power the origins of the internet in many ways. But they weren't really a consumer operating system. They weren't something for the masses. Mass consumption came about when Microsoft and Windows started to hit the scene. Microsoft took it from an environment where it was tightly coupled to a particular flavor of hardware or a particular brand of hardware, and they said, use any hardware you want, just as long as it has an Intel architecture chip. And it didn't even have to be Intel branded. It could be an AMD brand. I remember years ago there was Cyrix and other companies. So they had a very easy to consume and easy to understand model. We'll build the software, you run it on anything you want. And that really put it on laptops and desktops and really all kinds of devices. But then we all know Linux came along and opened that architecture and that ecosystem. Open was a better story for a lot of folks because it let them do things that Microsoft wouldn't allow. They could build new flavors of Linux, new distributions of Linux. Linux built specifically for high security environments. Linux specifically built for embedded devices. Linux runs on devices in this room probably all over the place. So the openness was a real big thing in this, in sort of the evolution of open source and ecosystems in general. Open was a very powerful concept. Let's look at one more and then we'll get to the punchline here. So BlackBerry, for all practical purposes, they invented the smartphone. Who do you imagine is in this middle column that made the smartphone mass consumable? Apple, right? Apple. Who's in the last column? Android. Everybody knows this story, so must have seen this before. No, I think it's just pretty self-explanatory. Open does have a role to play. Android is now the most popular smartphone platform on the planet, and it's because they were open with their choice of hardware platform, open with their developers in many ways, open with the people that were going to provide the services, and I think that same thing is going to play out with cloud. VMware invented virtualization for all practical purposes. I don't know if they really invented it, but they had a big role to play in it. Amazon has done a fantastic job, of sort of evangelizing the concept of cloud computing, cloud infrastructure, on-demand computing. We'll give them a big hand. Amazon did a great job, but OpenStack is going to open that up. It's still a bit proprietary. It's still a bit behind the wall. It's not something that anybody in this room can sort of consume and take advantage of on their own. They have to go buy it from somebody in the form that they want to sell it. And so I think OpenStack changes that whole dynamic. So ecosystems really do matter in this. And I don't think there's going to be too many more ecosystems than this. I think you'll have the VMware ecosystem for enterprises. I think you'll have the Amazon ecosystem for a while, as long as they are the big gorilla. But I think the OpenStack ecosystem is the one that I'm betting on, and the whole, Rackspace and a ton of other companies. So this is that list of companies that we use. I don't know if this is the latest, greatest list, but these companies, a lot of them are well-known companies. A lot of them are not so well-known outside of us cloud ecosystem folks, but we know a lot of those brands. So NASA and Rackspace were obviously behind it. Citrix and Cisco and Microsoft and Intel and AMD and Brocade and Dell, and I mean, there's a lot of names up there that are very recognizable. So there must be something going on in this ecosystem. Why is this happening? I think it's because these guys all want to have a role to play in this. They don't want to be sort of left out. And I asked the question, why does open matter in the cloud? And it's that very reason. It's because if you look at some of the models that are out there today, the cloud providers are saying, come buy cloud from us. Don't build private clouds. Don't look at any other model. Ours is the way, and if you're not using this, there's something wrong with you. You're not thinking about it right. Well, that's not true. You are thinking about it right. There is a bridge that needs to happen from on-premise computing to public cloud. There are some steps along the way. There are some different deployment models. I heard an example the other day that was a good one. I thought, I'm sorry I can't credit to somebody, but it's not mine. But they said, public cloud is like a bus, right? Everybody gets on the bus. It's more efficient, uses less gas. Everybody pays the toll instead of owning anything. So public cloud is like a bus. And so if you want the most efficient stuff possible, you'd go get on the bus. But buses are used all kinds of places, not just public buses, but what about the bus that the university system uses? And what about the bus that the private tour bus guys use? And what about the bus that the prison system uses to haul prisoners around, or the military uses to take soldiers all over the place? Those are all technologies like a public bus, but they're used in more of a private fashion. And I think that is an important concept to grasp and understand, that public cloud technologies can be used in different places besides just the public cloud, and they probably should. And I think that's, again, why OpenStack matters so much. And why does it matter for all these people on the list? I think it matters for them, again, because they have a role to play in the cloud just like they did in IT. This cloud thing feels like it's all new, but it's not all new, because a lot of the same players or a lot of the same vendors are popping up to start to offer cloud services. But again, in these big public cloud services where it's their way or the highway, you really don't have a choice around which vendor you use and which storage architecture you use and which network platform. And all of those folks that are very much a part of our IT ecosystem today, they have a role to play in the cloud as well. They are very innovative companies. They built billion-dollar brands, with innovation and new technology and bringing it to market. There's bound to be a role for them to play too. So I think that's why they're interested in this open concept. So I want to mention a few more. I talked a lot about OpenStack, but I want to make the point that it's not just about one particular project. It's about the concept of open clouds and open computing. So this is a project that Facebook did this year. Rackspace helped collaborate on it, but they did all the work. I'll give them the credit. They launched this project called the Open Compute Project. Open Compute was basically a way for Facebook to take the technology and the data center, the server, all the technologies that sort of powers Facebook, and start to share it in an open fashion. I think of this stuff as the foundation for a cloud, a public cloud of any size. This could be the most efficient stuff we've ever seen at this point. Most of us have never seen Google stuff, but what I understand is a lot of the capabilities that Google has, a lot of the people have left and gone to Facebook and sort of reinventing the technology in a new place. So this is very efficient hardware. It's a data center design that's extremely efficient. They don't use any chillers in their data center. It's completely chillerless, which means a lot of efficiency. And they've even given the specs for their hardware platform so that vendors like Dell and others can actually go and build the very same hardware and hand it to you folks if you want to build a cloud on it. So this is the concept of open computing. Other platforms are starting to pop up. VMware actually did this year as well. They launched Cloud Foundry, which is an open platform as a service project. It's an open source project that's sponsored by VMware. They're obviously going to have some commercial aspects to it, but essentially there is a back end that's built on open source, and eventually this may be something that runs on top of OpenStack-based clouds. It might be part of this ecosystem. Another company I'll mention, Red Hat, they launched OpenShift. I think that was a couple of weeks ago. So this is maybe a competing platform to VMware. Maybe it works in conjunction. I don't know. It has some time to play this out, and we'll see. But obviously, they're trying to solve a different layer of the cloud stack than we were initially trying to solve with OpenStack. OpenStack fixes the infrastructure layer for you, and then as you go up the stack, you're going to need tools and things for your developers. And I think they work probably in concert with one another. Every good platform cloud needs an infrastructure. And SaaS too, SaaS companies. There's not really, I don't have a good example of SaaS or software as a service, but even SaaS needs a good infrastructure underneath. So we're really looking out there at companies that are starting to think about building their cloud businesses, their SaaS businesses on top of OpenStack instead of reinventing that wheel. And again, there they feel very good about open source because they have portability for that SaaS application. It can run in their infrastructure, it can run in a private cloud infrastructure, or it can run in a competing public cloud infrastructure. So those are all very good models. So our vision is long-term, sort of this is a simplified slide that just sort of paints the initial vision we had for OpenStack. We want to make sure OpenStack runs in public and private clouds at Rackspace. We want to offer that to you if you choose to buy it from us. If you don't, you can go take the software for free. You can build a public cloud of your own. You can build a private cloud of your own if you're an enterprise, at another provider, or you can build it all in-house if you're an enterprise that has its own data center. We also want to drive some standards that allow for a variety of management platforms to sit underneath and control the clouds. If you think about when people want to build these federated clouds and they want to manage resources on-premise and off-premise, they need management tools to do that. And again, you want those management tools to be open because then they can control multiple flavors and multiple locations. And these are, I put up a few examples of companies that could potentially adopt these standards. CloudKick we acquired to help us start to do it at Rackspace, but I envision a number of companies getting on board and starting to build enterprise-type management tools for the cloud. So another thing we've done this year, we launched a group called Cloud Builders. So this was a team that is made up of some Rackspace employees and some employees of a company we acquired called Anso Labs. So Anso Labs was the consulting folks or the contractors that built NASA's cloud for them. So back when we partnered with NASA initially, they had their own team building their cloud. And along the way somewhere we said, well, let's buy those guys and bring them into Rackspace and have them help us build OpenStack. And then what we figured out is we needed not just building OpenStack, but actually helping people deploy OpenStack. We had all the expertise around it, so we needed to start letting that expertise come outside the walls of Rackspace. So we created this group. I call them consultants. They probably don't like that term, but that's sort of what they're doing. They're helping people with training and deployment and cloud management, architecture, support, all kinds of things that you'd imagine you'd need if you were to go and build an OpenStack cloud. So that's what they're working on. If you need our help, you can get it. If you don't need our help, there's a really great community around it. These are a few of the big deployments so far. I don't have a ton of names to show you because deployments, people have been waiting for the release of OpenStack that just launched at this last design summit. We considered that our first production-ready release of OpenStack. And so that third release was just launched. I envision we'll have a whole bunch more logos to talk about, but obviously Rackspace is betting its business on it. Internap is a competitor of ours who's done some work on building an OpenStack-based cloud. NASA is doing big things with it, and they're trying to evangelize it throughout NASA and throughout the federal government, so I think you'll see a bunch more on that category. And so I hope by the time I'm here next time, if Jeremy invites me back, I'll have a bunch more logos to show you and case studies. So what does OpenStack mean for you? You can run it at Rackspace, you can run it with another service provider, you can build it in your own data center, you can build a business like a SaaS or PaaS or whatever you want to build on top of it. If you need our help, you can use Cloud Builders to do that. If you don't need our help, you go join the OpenStack community. You can download the source code. It's all there. It's everything, including some really cool functionality on top, like a portal, like an iPhone, iPad, Android app, all kinds of stuff that we're contributing. It's not like it's just the bare necessities. It's actually a pretty good set of technology that actually takes you a long way down the path. So you could build a small cloud. I really hope that people start to come to our design summits if you're interested in contributing code or being a part of this ecosystem in a big way. Come to the design summit. That's where all the action is. We had 500 people in Santa Clara 3 or 4 weeks ago. The next one is in 6 months or 5 months from now, I guess. But I hope we can maybe double that, so 1,000 people. That'd be a really good goal. And if you really want to just find out more today, go to openstack.org. That's it. I think, do I have time for any questions, or you're not on? Okay.
Before we turn the microphones on, as John mentioned, of course, one isn't always necessarily invited to speak about Expo Silicon Valley. So let's make that open and say, if you think John Engate should be invited to speak in November at Expo Silicon Valley, please say aye. Aye.
Oh, good. Thank you all for saying that. That's
okay, let's try this.
Yeah, good.
I can just confirm that John Engate will be speaking in November at Expo Silicon Valley. Let's throw at him some tricks.
Anybody have any questions?
We just have a little bit of time for Cloud Expo.
What's your OpenStack cloud monetization strategy?
What's Rackspace's monetization strategy? That's a good question, because a lot of people don't understand how Rackspace makes money on all this. So number one, we do have a big public cloud based on OpenStack. So in some ways, it's a cost-saving strategy to have other people help us build the cloud with us, so we don't have to do it all ourselves. We don't really want to have thousands of developers building this. We want to have a few hundred, and then we want to lean on other people. So that saves us money. The Cloud Builders team charges money for their services, so they're going to make a little bit of money there. We're going to run big public clouds, so we make money on that, and we're going to host big private clouds, so we'll make money on that. We're not greedy. We don't want to own it all. We just want to do what we do best, which is offer great customer service on top of the cloud. Anybody else? One over there, one over here.
What is the thinking in the OpenStack about the manageability aspect of the cloud, the entire stack? I mean, you mentioned about open compute, open storage, open image services. What manageability? I mean, so one of the biggest challenges most of the company faces, there's not enough APIs out there where you can basically manage a cloud.
Yeah.
The entire stack of the cloud.
Well, okay, so manageability is a goal with OpenStack. You know, obviously the standards and the APIs that we've published are a part of that. The recipe for manageability relies on having some standards, because if you want a tool to manage it, you're going to want to have a choice of tools. You're going to want to have some tools that go further up the stack and manage not only the infrastructure but the platform and the apps themselves. If we don't get to a standard at some point, you'll have this disjointed, vast number of clouds, and some of them have partnered with vendor X, and some have partnered with vendor Y, and some have their own management story, and some are managed by third party. The standards are really the only way we get to a point where you have choice of manageability and you have full depth of manageability across the stack and across clouds, across vendors, because that's going to be another problem. People are going to want to deploy a multi-cloud strategy so that they're not all eggs in one basket, and you've got to have a way to manage across. So I think the foundation for manageability is standards, and I think open standards and open discussion around that. So maybe we'll have if you come to the Design Summit, you can propose a whole section on manageability and how that's going to play itself out. We don't think we have all the answers yet, but I think with an open community, with an open dialogue, we'll get the right answers.
Last question.
One more.
This may be sort of a hypervisor on a hypervisor kind of question, but would it be possible for someone to create an OpenStack lab at Rackspace? So if I wanted to set up an OpenStack lab, as if I had bought a dozen computers and wanted to play
Yes.
could I do it there?
Yeah, you can. You can do it. We are actually doing that today with the Cloud Builders team. We did that as a proof of concept. And we did a press release a few months back with Dell and Equinix and Rackspace so that you could do it outside of Rackspace on your own terms. If you wanted to build a little data center with a little test environment, we can do that. If you want to do it at Rackspace, we have our hosting business that we are now actively building private clouds for people in that hosting business. If you're really interested, call the Cloud Builders team and they'll help you through that. But yeah, absolutely. And you can even do it today. All the developers run OpenStack to test on their laptops. And the whole thing can be deployed in a pretty small environment. Obviously, you can't do big things with it at that point, but to test the functionality, to test the APIs, to make sure it works, do it on your laptop. So, thank you.
Sounds good. Can I ask you to take it offline?
Yeah, I'll be in the back of the room if you guys want to ask questions.
That's very kind. Let's give it up for John Engates, please.
Thank you.
Thanks so much, John. Great presentation.
Thank you.
As always.